Hey everybody, Rick Balkin at the University of Mississippi School of Education, Educational Research and Design. We're going to go over a two-way repeated measures ANOVA. This is a special case when you have more than one repeated measures over time and you want to compare those. In this example, I'm going to be looking at adolescents who were in residential treatment, and we're going to look at the changes in symptoms over time, both from the adolescent's perspective, how the adolescent feels their symptoms changed over time, and how the clinician rated the change in the adolescent's symptoms over time. We're going to run this in JASP. Let's get started. I'm going to share my screen. And here's my data set right here. ASX from baseline to week 6 is going to be the adolescent symptoms, and then we're going to have the clinician symptoms from which are baseline to week 6 as well. So I go to ANOVA, I go to repeated measures ANOVA. I'm going to put in rater, and I'm going to put in the adolescent as one rater, it's self-report, and then the clinician's rating of the adolescent's symptoms. And then my other factor here is going to be time from baseline to week 6. And from here, I'm going to put baseline, which is when they come in the first week, and then week 2, week 3, week 4, week 5, and week 6. There we go. And you can see right down here in JASP, I have adolescent baseline, week 2, week 3, week 4, week 5, week 6. So I can just take my adolescent symptoms here, highlight them and move them over. And then I can do the same thing for the clinician baseline through week 6, which is down here. So all my spots are filled. I'm going to have to look at descriptive statistics, estimates of effect size. I want to focus on partial eta squared. I want to look at assumptions, the sphericity assumption in particular, and have the greenhouse geyser option if I need it. And I also want to create some plots. I want to have my horizontal axis be time and my raters be my separate lines. So the first thing I do is I look at that sphericity assumption, and let's go down here, and you can see that I violated the sphericity assumption, which means I'm going to have to look at the greenhouse geyser option when I'm evaluating this. Here's my graph, and we can see both adolescents here and clinicians note a decrease in symptoms over time, but that the clinicians rate the adolescent symptoms higher than what the adolescents self-report. Let's go take a look at our data here. So do I have a significant interaction? I don't. So I can look at the main effects up here, and I can see that there's both a significant difference between the adolescents and the clinicians, and I can also see that there's a change over time. And here's my effect size with the clinician differences, with the raters differences being about 29.5% of the variance in the model, and the changes over time accounting for 37.1% of the effect in the model. So there's another way I could tease this out. And so, we can see that both adolescents and clinicians say that there's difference in the scores, and we can also note that there's a decrease in time. But what is that? What was their way to kind of look at what is the percentage of change over time from the adolescent perspective and the clinician perspective? And we can look at that by looking at percent improvement. The percent improvement is simply a variable that looks at the change from the baseline to the last score of week 6 divided by the baseline mean, or divided by the baseline score. So here I would just call this adolescent percent improvement, and I'd create a column, and I would make that baseline minus week 6 divided by baseline, and I could multiply that by 100 to get the percent change. Just kind of an easy thing to do here. And I could compute that column, and we see that added right here. So that this adolescent actually says, hey, I regressed. My symptoms are actually higher in week 6 than and you know, we would note here that indeed this adolescent said my symptoms were at 37, and then my symptoms were at a 62. So they say they regressed, that their symptoms are higher as a result of being in psychiatric hospitalization. But these other adolescents are saying, no, we improved, we improved. Let's look at the clinician responses also for each adolescent. And I could hit C, we'll just call this clinician percent improvement, and create a column. And that's going to be clinician baseline minus clinician symptoms divided by the clinician baseline. And I'll compute that column as well. And we have that here. Interesting. This adolescent is saying, I regressed. This clinician saying, no, the adolescent improved just a little bit. And so we can look at even some descriptives of these two variables of the adolescent and the clinician percent improvement. And we could, you know, ask for like minimum, maximum values, mean and standard deviation. We could also ask for a coefficient of variation. That's a neat one because it tells you how much variability is in each of the in each of the respondents. And you could see that the coefficient of variation is somewhat equivalent, but that adolescents say, ooh, I have an error here because that should be 0.103, that should be 10.3. Let's go look at that variable again real quick. Yeah, I forgot to multiply by 100. There we go. And we'll recompute that column. That'll fix it. Yeah, there we go. And so we see a 14% improvement that adolescents endorse versus a 10% improvement from the clinicians. You know, overall, not huge differences, right? You know, there's, you know, yes, there's differences, but they're and they're significant, but these aren't enormous. I mean, we could say, oh yes, there's a large effect between the two. We could say that, but looking at the descriptive statistics, you might even say that they're a little bit closer than what we thought. So keeping in mind there's only 13 participants, and so some of these values could be a little inflated. But anyway, that's the analysis for a two-way repeated measures ANOVA. Hit me up if you have questions, and I look forward to hearing from you. Take care.